Alrighty. Hi, everybody. My name is Isaac, and yeah, I will be your professor for the rest of the semester. Yeah. Once again, thanks to Walker for covering me. I'll do a further introduction, to have you guys get to know me a little bit better when I actually meet you guys in person. But for now, let's just go over some things. So, as I understand it, you guys have gone over some of the basics of Java already. Uh, how to, some of the basic syntax and stuff like that. So, I want to get into a little bit more about Java, um, some things about objects, some classes, and kind of just a couple of examples on how to use some things. So, I have here just a new file here, main.java. So we can see that our file name is main.java. So our class name has to be public class main. And then I've created a main function here, public static void main string array of args, right? All things that you have to do to get the program to actually run, right? So let's kind of decode this a little bit and look at kind of what a few of these are, right? So this up here, this outer guy right here, is a class, right? So this is the class level of the code. And then each of the guys in here are what we call methods. So we can create any number of methods, any number of classes. The only thing is that the class name has to be the same name as the file name, right? So in general, think of methods like functions. So coming over from Python from 201, right, we eventually made a lot of functions, right? So what you can think of methods are is they're essentially functions for specific classes. Think of a class like a program, think of a method like a function, all right? So the thing about classes is they're a little bit different than your kind of generalized programs in Python, right? So a class is an object. And we'll get into a lot more of what objects are, how they differentiate in a little bit. But first, we just need to recognize that a class is a thing in and of itself. So when we create a class, we can create instances of the class, right? So our class here right now is just, it's abstract, right? It doesn't exist. It exists, excuse me, as a theory. It exists as like a structure, but no actual implementations of this class exist, right? So we'll work on creating instances in a little bit as well. But think of an instance as, hey, here is your example. Here's your definition of your class is all in here. And then when we actually use this class somewhere else, that's an instance of the class. It's an instantiation of the class. And then the other big thing we need to know about classes is what's called attributes, okay? So these are basically variables. So in each of our methods, we can have variables. We can have things like int x equals 10. Whoop, semicolons, important. Int y equals 1, etc., right? We can have those in our methods. That should be pretty familiar, kind of like variables in your functions. The other thing, though, is that we can have variables up here in our class. These are called class variables, or they're called attributes, okay? So we can have variables up here, int x equals 10, etc., right? And it's going to act similar to global and local variables in Python, right? So a variable out here versus a variable in here. All of the functions, all of the methods can see our class variables, but other methods cannot see variables within methods. So it's important to differentiate a couple keywords here, and that is public and private. Public versus private. Now, I don't know how much you guys have talked about this yet, but the idea of public and private is basically what can be seen. So public means that anything that's public can be seen outside of this. It's not abstracted away at all. It's very clear to whoever's using this what each of these are. Whereas private means they can't actually access whatever something is. So if we create public methods, for example, then anytime we use this class, we can see these methods. So if we go back to our Python example, things like string, right, we can think of as a class. And things like string dot length, we can think of as a public method of string. However, we can also create private methods, and we can think of these as helper methods, right? So if we create a private, I don't know, add private void add number, something like that, right? We can give it a number. Whoop. Int num. And we can say, I don't know, num plus num. Int sum equals num plus num. Obviously, we're not going to do anything with this right now, so it's a little bit arbitrary. But we can see that this isn't something that's necessarily important for being outside of this code, but we can use it inside our code now. And we can say, hey, let's take our number, add number. It has to be main.add. It's fine. We'll talk about helper methods a little bit more. I think the problem is that actually needs to go down. So Java is a little bit trickier because the order you actually do things actually matters as well. Python was very forgiving. Java's a lot less forgiving. So again, we'll get into all of that a little bit more later, but I kind of want to just give you a broad overview on a little bit more Java things for now. So with that said, let's go back to our attribute here. Our class variable, we can make it public or private. So if you don't specify anything here, that means it's automatically public. So anytime you create an instance of this class, then that means that you can access and look at what this variable is. Now, a lot of times, this is theoretically okay, but we're going to try to avoid that because we want to use the proper channels for things. Now, I'll explain what I mean, again, a little bit later, but just recognize that we can have attributes here that are either public or private. Int y equals, I don't know, 5. Doesn't matter. Public, anything outside of this class can see. Private, anything outside of this class cannot see. So we'll just add some comments here. Can be seen outside of this class. Cannot be seen outside of this class. Okay. So let's talk about these variables, right? So in general, because the order we do things really matters in Java, we want to start getting into a habit here. And we want to start getting into a habit of anytime any variables we're going to use, we're going to declare them at the very top of our code. So let's say we need a few variables in main here. We need some product, sum, and we need a, I don't know, dividend, and don't need a divisor. Who cares why? Don't worry about it. Now, what we could do is what's called on the fly declarations, which means that we just create the variable when we need it way down in our code, right? So if we need a product, we don't necessarily need the product at the very beginning, right? We're multiplying two things together. Let's just create the product when we multiply things together at the bottom. That's an idea, but that's not going to be good form here. We're going to want to look through our methods are code. And any variables that we use, we're going to just declare them all at the top. Now, we don't need to know what they are here. We just need to know that we're using it, right? So if we, again, have this product, sum, and dividend, let's assume they're all going to be integers for now. We will create int product, int sum, and int dividend. Now, this is just saying, hey, we're going to take these words and we're going to reserve them. These words are ints. This is a variable. It's going to be an integer. We're going to use it later. This will help keep track of all of the variables we're actually using in each of our methods. Now, this may seem a little counterintuitive right now to try to figure out everything in the beginning when we could just kind of do it as we go. However, if we do this, then we're going to create a structure for our code. And if we have a good structure and if we have a good plan, then that's going to make sure that our code is a lot more readable and it's a lot easier to navigate through, right? So this is for readability and navigation. All right. So the variable naming conventions you can see a little bit here. They're going to be a little bit different from Python, right? So in Python, we use what's called snake case, right? So anytime we had a variable, we would separate words with underscores, right? So if we wanted, I don't know, int variable one, var1, we would say int var1, right? And this is the Python way. And this is bad. We don't like it. We don't do this. What's also nice, just a quick aside, in Python, everything was dependent on spacing. It was dependent on tabs, right? So, excuse me, sorry. If you wanted to indent something, that would create kind of a separate block. The nice thing about Java is that these curly braces act as our kind of indentation here. So we can tab as much as we want, has no effect on the code. Int product, int sum, int dividend way out here, way out. It's going to get mad at me. It doesn't like when I do this. This is all going to function the exact same. All right. Now, obviously, we're not going to do this because this is ugly. And if there's anything we hate, it's ugliness of our code. But we can indent a little bit like this just to make it a little bit easier to read to kind of see our subsections here. Anyway, going back to our variable naming conventions, the Python way is snake case, right? So we're not going to do snake case. We're going to do what's called camel case. Oh, come on. Java way. Good. It's called camel case. Now, you may be familiar what camel case is, but it's the idea of a camel has humps, right? It goes up and down, and so our code will as well. So if we have, I don't know, a multi-named, a variable, variable var, I don't know, variable A, B, C. We're going to create all one word here. No spaces, no underscores between them, but we're going to capitalize the first letter of each following word, right? Alpha, beta, Charlie. I don't know. We're not going to capitalize the first letter, but we're going to capitalize every other letter of these next words, right? So this is the way we want you to do variables in this class. If you run it through the code checker and are using like snake case or not using camel case, you probably get dinged a couple elegance points. So again, just use camel case, make sure you get your points, keep it easy, right? The other variable naming conventions that we have to talk about are constants. Whoa, don't need to go over there yet. All right, so we'll call this Yep. Variable naming conventions. Now let's talk about constant naming conventions. Now, if you remember in Python, constant naming conventions, we could sometimes have constants in our code, right? This was something that we declared at the very top of our code with all caps, and it was just a value that wasn't changing, right? So that's how we got through like magic numbers or things like that. We can do the same thing in Java. What constants look like in Java, though, is that we have to actually use a new keyword here. We have to use this final keyword, okay? And what final does is it makes this, whatever variable you're working with, unable to change. Whereas in Python, even if you named something a constant, made it look like a constant, you can still change it because Python isn't as strict with the rules. It kind of plays a little fast and loose. Whereas in Java, if we have a constant here, string constant, this cannot change, right? So if we create our constant, say it's hi, I don't know, let's say hello, be a little bit more formal. Then if we try to change it later, this constant, we're actually going to make goodbye now. It's going to get mad at us. It's going to say, hey, you can't do that. Cannot assign a value to a final variable, which just means, hey, you declared this as final. That means it's not changing. It's final. You cannot change it. So if you try to change it, you'll get an error. But the difference is that, again, like Python, we do not have our finals in lowercase. We keep them all caps. So we'll go final constant. And we'll just keep that naming convention for anything else. Final int constant number 2. I don't know. 2. So this is the one case where camel case doesn't actually apply because everything needs to be in caps. So you can, if you'd like, separate it with underscores, but just make sure that all of your words are in caps. All right. And then last but not least, talking about kind of variables, naming conventions, things like that, we need to talk about reserved words. So these are words that you cannot use for variables, things like that, right? These should make a fair amount of sense. It's class, final, public, and private. So class you can't use because obviously if you say class, then it's going to think you're trying to create some sort of class. If you say final, it's obviously going to think you're trying to create a final. Public and private cannot be names, and then static and void. Now, we haven't talked about what static or void really means. We'll get into void in just a minute. Static, we're not going to super talk about yet because it gets a little confusing. Isn't something you need to know right now. But just recognize that these are words that we cannot use for variables, so don't try. Now, let's talk about types some. So this can all go in our variable naming convention section. We'll create a block comment here, make it look a little bit cleaner. Now let's create another block comment for our types. So there's something first that we have to recognize with types in Java. So types are things like your ints, your floats, your strings, your booleans, things like that, right? Things that we know what types are. We've done Python before. However, there is a couple different types, of types. There are objects and there are primitives. Objects versus primitives. So what objects are is that they're going to be anything that's like a class, right? They're going to be something that's defined like this. It is a class. It has methods. It has constructors, getters and setters, things like that. So what this is it's going to be a little bit more complex. More complex, takes more space, time, but it has more, let's call it usability. Because it's more complex, there's a lot more that you can do with objects, right? So objects are going to be things like a string. Wow, try to type. Example string. Or something like a scanner. Example scanner. We'll import this class real quick. So in the same way we have to import, quick aside from this, well, just because it popped up, in the same way we have to import like things like math or something in Python, not everything comes in the default package of Java. So what I did just there is I just imported java.util.scanner. Scanner is just an example of an object. We'll talk about scanner more again in just a minute. Scanner is how we will kind of get inputs from the user. Primitives will look a lot more like things that we're familiar with, right? So these are very basic. Can't do a lot with them in terms of their functionality. Like they're not going to have methods. You can't get the length. You can't just call like int.length or something like that. But you can, they're quick. And they're speedy. And they don't take a lot of space. Small. Come on. So these are going to be things that we're very familiar with. It's going to be int. Example int. Things like a float, a double, things like that, right? A character is a really good example of or even a Boolean. These are all primitives, right? So again, there's not a lot you can do with them. Whereas like with example string, right? With a string, we can call functions here. We can look at, make it to lowercase. We can call, I don't know, the index of things, etc. Right? There's a lot of things that we can do with an object. With a primitive, we don't have that. So if we call xbool dot, these aren't really things that you need to worry about. These aren't functions. These aren't methods that you can use. It's a little bit, again, a lot more simplistic. It's a lot more primitive. Wow. So again, the primary difference why we have the two of these is just the time and space complexity of both of them. You can do more with objects, but it costs more, whereas primitives, they're going to work a lot better when you're dealing with lots of them or when you're dealing with super basic functionality, right? We don't need a lot of complex functionality to hold a number, or we don't need a lot of complex functionality to hold a single letter. But when we're dealing with maybe large strings, large words, or even paragraphs, then we may need a little more complexity. All right. So that's some of the basic stuff. Now let's kind of see a little bit of what we can do. So methods have a couple other things that we need to talk about, and that's return types, right? So in Python, if we wanted to return something, we would just like return things, right? We need to just very much specify what we're returning here. So if we want to return something, then we need to specify the type of the thing we're returning. So let's say I want a method here that just gives you a number, right? So we're going to make it a public method. so that it can be seen, it can be ran, and it's going to return an int. And then we'll just call it return int. Something like that, right? Now notice this is mad at me because I'm missing a return statement. And so if I just return 0, something like that, it won't be mad at me anymore. So you just need to specify the type that you're going to return if you want to return something. Now, if you don't want to return anything, if it's just doing some math, things like that, then you just call void here. But you do have to specify if it is returning anything, if it's not returning anything, right? So you can't just say public example method, something like that, right? It's even getting mad at me here. Yeah. It's going to say missing return type required, right? You have to specify some sort of return type, even if you're not returning anything. So again, if you're not returning anything, you just say void here. All right. So let's combine a little bit of what we've talked about here and create an example class, all right? So I'm going to create a new file here, a new Java class, and we're going to create a rectangle. Public class rectangle. So first, let's think about what kind of attributes it has, right? Because we need to define the variables of a rectangle. What are the two most important things a rectangle has? Well, if we draw out a rectangle, we can boop, 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 draw a rectangle in your brains. You'll see that there are two sides, right? There is our length and our width. So I'm just going to make those integers, right? And then what we're going to do here is we're going to make them private. I don't want people outside of this class to be able to go just change these willy-nilly whenever they want. I want them to be able to go through my methods, go through the ways I want to change them. So we're going to see a couple things now. Some of the most common methods that you're going to create in your classes are getters and setters. Whoop. So these might be called, you might see these as a getter is a accessor, and a setter is a mutator. Same things. A getter, an accessor. I like getters and setters just because it's basic, it's easy to think about. But the basic idea here is that you're getting something, you're accessing it, right? Or you're changing something, you're setting it. So typically we'll have getters and setters for each attribute that we have here. So for length, we need to be able to get length. So we'll create a public function, public int get length. Now you'll notice that IntelliJ will autofill these because getters and setters are so common that if you have these attributes here, then it will pretty easily know what you're wanting. So we'll have get length, and it will just return length. That's all this is going to do. And then our setter for length, public int set length, int. Oh, one other thing. These are supposed to have underscores in front of them. So, one thing I forgot to talk about. Common syntax with these class attributes is that we just put an underscore in front of them. That underscore just lets us know that it's a class attribute that we're working with rather than some local variable here or something like that. So sorry I forgot to mention that. But yeah, when creating these variables up here, try to use these underscores with them. So going here, our getter gets length. We need to say underscore. So we'll return length, and then our setter will set length. So we'll say our global variable, our class attribute, right, underscore length, is equal to this input, this attribute of what here that we're getting, which is non-underscore length, right? Set length is not going to return anything, sorry. So these are very basic getters and setters. They don't do a lot, right? Our methods should be very basic. They shouldn't be doing a lot of things, right? So set just sets it. Get just gets it. Now you may say, why don't we just make these public and let the people do what they want with them, how they want to do them? For something as basic as a rectangle, it might be fine, right? But the answer to that question typically is going to be, well, when you're dealing with more complicated stuff, when you're dealing with large code blocks or something like that, then you might not want them to go change things willy-nilly. You might want them to go through your right paths, because maybe get length needs to add something to the length, or maybe set length needs to add something to the length, or maybe get length needs to return it in a different way, right? Maybe you're storing length as a float, but you want to return it as an int, things like that. So we're just going to get in the habit of doing this so that when it's actually important to do it, we're used to it. So then we're going to create getters for our other one. So we'll create a public int get width, return width. And our other setter will be public void set width. Width equals width. All right. That is most of what we need to do here. But there's kind of a couple other things we might want with a rectangle. We might want to think about maybe another thing of rectangles. Maybe, so let's call this other methods. This will be our other methods section. We can even tab these over to make it prettier. Hey, these are our getters. These are our setters. And these are our other methods. So we might want the area, right? So we can say public int get area. Now we don't need any attributes to keep track of area, right? Because area is dependent on length and width, right? So we don't need to store what the area is. We can just calculate it whenever we need it. So we can return length times, not length, length times width. There we go. That's all we need to do for get area. And let's do one more thing. Let's add comments. So there is a special kind of comment for classes and methods called Java docs. Now, if you remember, a single line comment looks like that. Single line. 2 forward slashes. A block comment looks like a forward slash and an asterisk to start, and then an asterisk and a forward slash to end it, right? Block comment. What a Java doc is for is it's to keep track of what each of these classes and methods do, right? So what a Java doc will be is it will be a forward slash and 2 asterisks. And then you'll create Java docs for any methods you create or any classes you create. So we'll just do a brief description of what our class is here. It's a rectangle. You know what that is. Obviously, be a little bit more descriptive. I'm going to just be a little snarky because it's my code. So for our get length, we'll do this. Now you'll notice here that there's an at return, and there will also be at parameters when we get down here. So what these should be is descriptions of what you're returning, right? Returns the length of the rectangle as an int. And what you'll find for getters and setters is typically the descriptions will be pretty much what they are, right? So this is a description of what the function does, and this is a description of what it's returning. Considering the function has one purpose, and that's just to return something, it might look pretty similar. You could also just say @return is length of the rectangle. Now we will continue our Java docs here. Boop. Returns the length, or returns the width of the rectangle as an int. Boop. So why this is useful is that when we are working with an API, or basically just a description of the code, we can look at that API and it will generate descriptions of each of the functions or each of the methods that you're working with based off of your Java docs. So it makes it easy to just go and get a quick overview of what you're working with. We can see that actually if we are working with string here. Enable string dot, and I think it should, not gonna tell us. So sometimes it will give the Java docs on something like this, but documentation. Here we go. So this is the Java docs for each of these functions, right? Or each of these methods. So at the @params tag this is what you would have written there. The @return, this is what you would have written. The area above both of those, this is what you have written, right? So it gives a nice description on what each of these do. If you're ever like, hey, what's the difference between this content equals and this content equals, right? Difference is character sequence versus string buffer. What those mean, don't worry about. Just for example stuff, right? So then we'll pop down here. Boop. Wow. Good try, Isaac. So that's the length attribute of the rectangle. Length of rectangle as an int. Now it's important to specify the type of whatever your parameter is, just to make sure that your users are using it correctly. Let's get the spacing a little bit correctly here. And then I'm just going to copy this because it's going to be pretty much identical for width. Width. Parameter width is the width of the rectangle. So that's the width. Yep. And then last but not least, we have our get area here. Boop. Calculates the area of the rectangle and returns it as an int. Area of the rectangle as okay. All right. Now notice all of this isn't really doing anything, right? We've created an entire structure here, what the rectangle is, right? But we haven't created any instances of the rectangle. So let's create an instance of the rectangle. I'm going to go over to this other class here. It's just a test class. It's in the same folder as my rectangle class. And I'm going to create a rectangle. Now you may say, well, what type is a rectangle? Well, it's type rectangle. So in the same way we can say int var equals 1, we can say rectangle var rect equals a new rectangle. Now what this is going to do is it's going to actually create an instance of our rectangle. So this variable here will be our variable that actually holds the instance of our rectangle. And then we can actually create parts of the rectangle with it, right? So we can call our var rectangle and we can say, hey, let's set the length to, I don't know, 5. Let's set the width to 2. I don't know, arbitrary numbers, right? And again, if we want to avoid things like magic numbers, we can say like, I don't know, int length equals 5, etc. Right? I'm not going to do that right now. I don't want to keep typing. But then we can go ahead and print our, let's say, area, right? So we can call var rectangle dot get area. Add our little semicolon after it. Boop. And I'm going to run this. Test. It's going to run. Hey, look, our area is 10. Now, so our length is currently here. Our length is 5. Width is 2, right? Now I'm going to call our thing again and change the width. Change it to, I don't know, 4. And let's call our rectangle dot get area again. So now, just keeping track of everything, our length hasn't changed. It's still 5, right? But our width has changed. It's now 4. So if we run this, it should print first 5 times 2, which is 10, and then 5 times 4, which is 20. And it did it. Great. So you can see it's working great. It's functional. Love it. So what we're going to work on next, not necessarily in this video, but just kind of moving forward, is talking about scanners, right? So I just want to do a quick explanation on what a scanner is, because that's how we'll be getting our inputs. So I'm going to go ahead and do all this and create a new scanner real quick. So we have to import java.util.scanner. And first we'll create a new scanner. We'll call it, I don't know, SC. New scanner. Boom. So this creates an instance of a object of type scanner, right? But it's mad because it needs something right here. So we have to point it at the correct location. Now, if we're wanting to get input from the user, we will point it at system.in. And then anytime you want something from the user, you can say system.out.println. Hey, you typed this. Sc dot, well, let's add it to a variable first. String variable equals sc dot next line. And this will give us the next line, basically whatever line they just typed, as a string. All right. Var. Boop. So we'll run this. I typed this. All right, so this is an input I'm giving it. We're going to run this. Hey, you typed this. I typed this. So we'll be playing with scanners some on Friday with the in-class assignment. So if you don't know, if you didn't take 201 or for example, the general structure of how this class will work is that I will typically lecture around 1 day a week, and then we'll more or less do in-class practice for 2 days a week. And so that will be all in partners, things like that. I'm not exactly sure what this Friday is going to look like because I might have a prior obligation. So I'll keep you updated with that. Worst case scenario is that I will just do another video on an explanation of whatever the in-class assignment is, and you guys will practice it on your own, and then just watch the video if you want the explanation. Anyway, so that is, I think, everything. Thanks for listening. Thanks for chugging through it. And I hope to actually see you guys physically soon. Hope you guys are doing good with the ice apocalypse. All right, see y'all.